Hello everyone, welcome to my channel again. So in this lecture we'll be discussing on convolution. So convolution is a very important term in digital system processing. So in order to understand convolution, let's think a system, a digital discrete system, or LTI, linear time invariant system. So that linear time invariant system has a specific response or behavior, and we need that behavior. That's why we design a system. We design system so that the system can shape our input to the needed output or to the required output. So basically, when we say the signal has convolved to with a uh, system response, we are saying or we are computing that uh, the influence or the effect of the system response on the input signal. So convolution is actually, when we say convolution, uh, we are actually computing uh, the influence or the overlap of the input signal with the system response. So this is an introduction. So in discrete system, convolution is a mathematical operation that combines two sequences to produce a third sequence that represents how one of the original sequence overlaps with the other as it is shifted through time. When we convolve two sequences in discrete systems, we are essentially computing the overlap between two sequences as one of them is shifted through time. So to explain this, let's consider an example where we have two sequences xn. So we can think of xn as an input signal and hn as a system response. So if we want to filter, for example, we can take this system uh, as a filter, right? So this our system is a filter or a digital filter, and h of n or hn is the mathematical representation of uh, the system behavior or the system response. So if we want to filter the signal by convolving it with hn, we start by aligning the first sample of hn with the first sample of xn. We then multiply the overlapping sample of xn and hn and sum the products to obtain the first sample of the output sequence yn. Then we then shift hn by one sample and repeat the process to obtain the second sample of yn, or the output. Sorry about that. And we can continue this process until we finish convolving. So until we have convolved the entire sequence. Alright. At each step, we are essentially computing the overlap between xn and hn, as hn is shifted through time, and summing the product of the overlapping sample to obtain the output sequence yn. So the mathematical representation of convolution is yn summation of hm times x n minus m. So what we are doing here is we are convolving the input x n with hm, but in order to do that we have to align it. So that's why we are subtracting m from n. You see, we have to align it first with hm. So this is the handy way of the mathematical representation of convolution. So xn is the input signal, hn is the system response. So this asterisk is a sign for uh, convolution, not multiplication. It's convolution in DSP. So the process, the stages involved in the above operation are like: first, fold or reverse the sequence xm. So we have to reverse xm around m equals to 0 to give x minus m. Then shift the sequence x minus m to the desired value of n to obtain x n minus m. So forming the product hm times x n minus m sample by sample for desired value n, summing the product over the index m resulting in yn for the desired value of n. So you can go through these notes, but I will show you example. That will be easy if we see example. Okay, so this is xm. Alright, so determine the output of system when xn equals to 2, 4, 6. So here the input is xn, and its discrete value, or the value of each sample, are given here, that are 2, 4, and 6. And hn is the system response, and the value for each sample, or n actually, index is given as 1, 3, and 5. So what we'll do first is we'll reverse, or we'll fold xn around 0, or around m. Okay, so by reversing that, we'll find this kind of shape. Alright, so m is 0, 1, 2, 3, 4, and hn is the system response, is 1, 3, 5. So we already have folded or reversed xm. So when we reverse it or fold it, x minus m is 6, 4, and 2. So here what we'll do is we'll multiply the first value of x minus m with hn, then 2 times 1 is 2. Okay, let me use 2 times 1 is 2. You multiply these two values first, and then shift it to the right so that it might be aligned with hn. Then multiply 3 times 2, 1 times 4, so 2 times 4, sorry, 1 times 2, 1 times 4 plus 3 times 2 is 4 plus 6 equals to 10. then shift it to the right again so that it may be aligned completely. So 1 times 6 plus 3 times 4 plus 5 times 2, which gives us 28. And now you shift it to the right one more time. It will be like this, and it will be like 3 times 6, 5 times 4. That is 38. And for one more time, like for one, well, for the last time, we'll shift xm by 4 units to the right. So this will be 5 times 6, and it will be 30. So what we are doing here is we are adding the summation, adding the product or summing the product of each and every value of the input signal with the system response as it shifts in time n. So by doing that, the output at 0 will be 2, the output at y1 is 10, the output y2 at n equals to 2 will be 28, the output at n3 will be 38, the output at 4, the value at n4 will be 30. So yn, or the output, will be 2, 10, 28, 30. Thank you for watching.